Guys, Mr. Bowman here. In this video, we're looking at 1.2 Algebra, which is the MCAT, and we're focusing on all the excellence questions from the 2016 exam. So let's get straight into question number 8. Our wonderful wordy ones, which come up every single exam. Breaking through the question, we've got Rane and Hone. So there are two people. If Rane gave Hone $20, they would have the same amount. Instead, if Hone gave Rane $22, Rane would have twice as much as Hone. How much money does each person actually have? So the first thing I need to do is probably need to define my variables. So we're going to say let R equal the money that Rane has. And then we're going to do the same for H. That's the money that Hone has. And from that, we can form some algebraic expressions. So focusing on the first one, if Rane gave Hone $20. So what that is saying is Rane, his starting amount is R, and we're going to take away 20 because he gave someone else $20, so he's 20 less. Same as the equals, and that's Hone, and Hone receives that $20. So this here is basically the $20 going from Rane to Hone. So that's our first equation that we can look at. We're then going to look at the next one. Instead, if Hone gave Rane $22. So this one here is going to be Hone minus $22. That should be equal to Rane plus $22. So $22 has been given to Rane. And this time around, it's a bit trickier, so twice as much. So for them to be equal, we now need to multiply Hone's sign by 2. So that means this here would come to this, and the original amount, Hone minus 22, would be twice as much. So we've got our two equations. Hopefully that makes sense. We're now going to get into the algebra, the rearranging part of it. So probably going to start off with the left-hand side equation, and simply I'm going to go plus 20 plus 20, so R is equal to H plus 40. I can now, this R over here, I can substitute this in, and the right-hand side will be left with an equation with H only, which we're a big fan of. So this R is going away, so it's H plus 40 plus 22 equals, and I'm going to expand this at the same time, 2H minus 44. I'm going to simplify this, that there's 62. So we're going to have H plus 62 is equal to 2H minus 44. I'm going to go minus H, get those letters together. 62 equals H minus 44. I'm now going to go plus 44 plus 44. Hopefully I'm getting my maths right, but that there is 106 equals H. So that tells us that Hone has $106. I'm going to put my unit sign there just to be sure. I now need to figure out R, or Rane's one. We've already got a really simple expression for Rane up here. So what I'm going to do is I'm now going to put that H into this equation here. So this H here is going away, so that should be equal to 106 plus 40, which is equal to $146. So Rane has $146, Hone has $106, and we've answered the question. On to question number 9. And this question is a little bit different to other MCAT questions. We've been told that A is equal to that mess and B is equal to this mess. We've been told to give an equation for A in terms of B. So that means our end goal is A equals some kind of mess with B. And the issue we've got here is that N, we need that gone away, so that needs to somehow go away. When I first looked at this question, I actually had no clue where to start. So my starting point was just expanding the heck out of everything. I started with B. I randomly picked B. I don't think it matters where you started though. So B is equal to 2n plus 1, n minus 6 plus n squared plus 3. So expanding the brackets, we've got 2n squared minus 12n over here plus n, and then minus 6 plus n squared plus 3. And that comes to my n squared, so I've got 3 of those, 3n squared. Now dealing with my n's, 11n, and I've got my numbers there, minus 3. So that was my expression for b. Not really helpful. The only thing I thought was 3n squared, and when I expanded the a value, I was also going to get 3n squared. I thought that might be useful. And that got me to expand a as well. So let's go ahead, expand a, 3 in bracket n squared minus 4n plus 2 plus n. Expanding away, we've got 3n squared minus 12n plus 6 plus n. And let's group the n's together there. 3n squared minus 11n plus 6. So at this stage here, I had a lot of interest. I was really stoked with how I went on. So you can see they both got 3n squared minus 11, 3n squared minus 11. The only difference being the constants at the end. So thinking about this, I'm trying to get a equals something. So what I'm going to do is I'm going to be a bit cheeky. 3n squared minus 11n minus 3, that there was b from above. But the only issue is I've changed this a little bit. So if I've done a minus 3 here, I'm going to do a plus 3 here. So those add to 0, so I haven't changed anything. And then I'm going to do that plus 6 from before. So you can see in the middle, I've added in a plus 3 and a minus 3, and that helps me match what I've got before. So simplifying all this, this part here, 3n squared minus 11n minus 3 is b. So that means b, and then we just simplify the rest, plus 9. And there's my expression, a is equal to b plus 9. So very tricky question, very annoying one. I definitely get a lot of people would have struggled and missed that in the exam. We are now on to question number 10, and we've been asked for what values of x will this equation be true. So let's start off by jotting the equation down. So 4 times 2 to the power of x is equal to 2x, also 2 to the power of 6x plus 3. So straight away, I know I've got some unknown powers from dealing with an exponential equation, which means I need the same base numbers. So I've got the same base numbers here. That 4 is a bit annoying. Luckily here, 4 is 2 squared. So I'm going to change that times 2 to the power of x, and that should be equal to x to the power of 6, oh sorry, 2 to the power of 6x plus 3. I can now simplify this expression. They have the same base number, so I'm going to add the powers together. So 2x plus 2 is equal to 2 to the power of 6x plus 3. I can now cancel out those base numbers, leaving me with x plus 2 is equal to 6x plus 3. Liking this, this is just a simple linear equation that I can go ahead and solve. So I'm going to do minus x first, minus x over there. So 2 is equal to 5x plus 3. Now I'm going to go minus 3, minus 3. So we've got negative 1 is equal to 5x. And finally, divide by 5, divide by 5. X is equal to negative 1/5. So pretty straightforward question if you are able to do that initial simplifying, which will then let you cancel out the bases. And 11, and we've got a nice messy one again. For what values of x is this inequation true? So we have an inequation. I wouldn't stress too much about it. Let's just jump into it and see what happens. So we've got x minus 2, x plus 2. When is that greater than x minus 2, x plus 3? So initially looking at it, I'm thinking this is going to be a quadratic in equation, unless there's some way for us to cancel out all the x's. Yeah, but I suppose let's get in and see that. So what I'm initially thinking is I'm probably going to expand everything. And this side here, that's a difference between two squares. So it's going to be x squared minus 4. When is that greater than x squared plus x minus 6? At this stage here, the x's are on both sides, so they actually cancel each other out. So we're going to have negative 4. When is that greater than x minus 6? And at this step here, I'm going to go plus 6, negative 4 greater than x. Oh, sorry, negative 4, positive 2 greater than 6. Or you can flip that around, other way around. When is x less than 2? Geez, I had a bit of a nightmare with those last bits, but we got there at the end. To question number 12, and we've been asked if n is a whole number, for what values would make this inequation true. So let's start off by jotting that down. So 6 times 2 to the power of n plus 1, when is that greater than 123? So first step here, I know it's not going to be a fun question, but the whole number there does give me a bit of an idea. But I'm going to start by simplifying first. Well, there's no way I'm getting that 6 to have a base of 2. So what I'm going to do is I'm going to move it to the other side as division. So I'm going to go divide by 6, and I've then got 2 to the power of n plus 1. When is that greater than 20.5? I'm now at a bit of a dilemma. So 20.5 does not have a base of 2. So I now need to think about my powers of 2. So 2 to the power of 1 is equal to 2. 2 to the power of 2 is equal to 4. 2 to the power of 3 is equal to 8. 2 to the power of 4 is equal to 16. And 2 to the power of 5 is equal to 32. So I've listed all my powers, and I'm going to stop here because 32 is greater than this 100, also this 20.5. So 20.5 would be sitting in the middle here. I now need to figure out which of these, am I looking at the 16 or am I going to use the 32? Which of them do I actually care about? And thinking about the question, I've been asked, when is this expression greater than this one here? So what I'm going to do is I'm going to be using the 16 because every whole number greater than that 16 will make this an equation correct. So we're going to change this to 2n to the power of 1. When is that greater than 16? So we've got that there. Let's change 2n plus 1 greater than 2 to the power of 4. We can cancel out the bases now. So we've got n plus 1 is 5. Oh, not sure why I wrote a 5 there. It's definitely a 4. And then we've got a minus 1, n greater than 3. So what this means is, for any whole number, that means if n is equal to 4, 5, 6, 7, anything above that, that means this inequation will be true. That means 6 times 2 to the power of n plus 1 will be greater than 23, but it won't be greater than 123 if n is equal to 3, because that would have been 16 up here. So hopefully that makes sense. Let's move on to question number 13. Okay, so we're basically asked to solve this messy equation, and I don't mind questions like this as I'm jotting down the thing, minus 8 over, we've got these brackets, because this here is really just some fractions, and I know how to deal with fractions, and I'm quite confident with them. So my first thing here is, messy quadratics, I need to simplify that fraction as much as I can. So the bottom's already factorized, so I'm going to look to factorize that numerator. So what adds to 2 and multiplies to negative 8? That's going to be positive 4 and negative 2. So they're going to be my brackets. So x plus 4, x minus 2 over x plus 2, no, x minus 2, and that should be equal to x over 2. And I like this because I've got the same bracket on the numerator and the denominator, so they're going to cancel out. X plus 4 over x plus 2 is equal to x over 2. We now do a bit of a cross-multiplying approach to get rid of all the divisions. So we've got 2x plus 4 is equal to x plus 2. And looking at this stage, I'm going to get an x squared here. So I'm thinking I've just got a quadratic equation here, but let's see what's happened. So we've got x squared plus 2x is equal to 2x plus 8. The two x's cancel each other out, leaving us moving over here. 8 is equal to x squared. I actually don't have a quadratic equation, and I can simplify that by square rooting both sides. So x is equal to plus or minus the square root of 8. To put it another way, x is equal to the square root of 8, or the second answer, x is equal to the negative version of the square root of 8. From memory, you didn't need the plus or minus stuff to get full marks. If you did say the square root of 8, you would have got full marks for this question. We are now on to question number 14. Breaking down the question, we've got Raj has kicked a ball, and there's the flight of the ball, goes up, then back down to the ground. That flight can be modeled by this equation here, where x and y are both meters. For what percentage of the horizontal distance does the ball travel when it's above 3 meters or more. So there's actually two things I'm looking to calculate here. So the first step here is I do need to calculate that horizontal distance. And once I've got that, I need to calculate the distance that the ball is above 3 meters. So distance above 3 meters. Once I've got those two numbers, I can go the distance above 3 meters divide by the total distance to get that percentage, which they asked us to. So I guess the first thing to note is if we draw a bit of an x and a y axis, the ball going up and down, the total distance really just would relate to the start point to when the ball hits the ground next. Those are the two x-intercepts. So let's work with the equation here. So we've got y is equal to negative x squared minus 4x. And at those x-intercepts, we know that y is equal to 0. So we're going to substitute that in. So 0 is equal to negative. And I'm going to actually factorize that thing there. So that's going to be x minus 4. I'm now going to break it into its two answers. So x1 will be equal to 0 and x2 will be equal to 4, which means this has a horizontal distance. I'll write HD of 4 minus 0, which is 4 meters. So there's my horizontal distance. I now need to figure out the total distance the ball travels when it's above 3 meters. So if you think of a line, so this is my 3 meter line, I need to figure out when the ball, or how far this gap is here. And luckily, if you go back to the y-axis, that would be 3. So I know y is equal to 3. So I'm going to be looking to substitute that in. So starting off with my equation again, this is my model, but I'm going to use this bit here just because it was simplified and easier to deal with. So we've got negative x minus 4, and when is it above 3 meters? So I'm substituting in that 3, negative x minus 4, just going to expand everything now, so that's negative x squared plus 4x. Everything to one side of the equation to be able to solve this quadratic. So x squared minus 4x plus 3 is equal to 0. So now I need to think what adds to that negative 4 multiplies to that negative 3, and hopefully you're thinking negative 1, negative 3. So we've got x minus 3, x minus 1 is equal to 0. Two answers are nice and easy. X is equal to 1, and the second answer is equal to 3. So the distance here, so the distance above 3 meters will be equal to 3 minus 1, which is equal to 2 meters. I can now find the percentage. The percentage is the easiest part here. It is going to be 2 divided by 4 times 100, which is equal to 50%. And that there gets you the excellence mark for this question. A lot of working here, but quite an easy question once you get through all the steps. And now on to question 15, and we've been given an area formula. There's the equation of the formula, and then if the area was 128, what values of x are you interested in? So jotting down my formula, area is equal to x squared plus 4x minus 12. And I've been told what the area is, so I'm going to take away the a and put in the 128 is equal to x squared plus 4x minus 12. Quadratics need to be equal to 0 to solve them, so I'm going to go minus 128 minus 128. So 0 is equal to x squared plus 4x minus 140. I'm going to factorize now, so that there's going to be minus or plus 14 minus 10. And that's because they add to positive 4 and they multiply to negative 140. And I'm going to get my two answers here. So the first answer of x is equal to negative 14. And the second answer of x is equal to positive 10. Now, this one's a bit weird. We've got two answers, but we are dealing with a rectangle. So this negative one is a bit weird because when have you measured a rectangle and it's got a negative dimension? So here onwards, I'm going to write x cannot equal to negative 14. And that's because rectangles can't have negative dimensions. Rectangles can't have negative dimensions. Therefore, x is equal to 10 and our units centimeters. So a really bread and butter MCAT question. eliminating answers. This part here is how you moved your answer. So over here was a merit, and you did that. That's how you upgraded it to an excellence. Question number 16, and this question, really straightforward. We've got a whole bunch of words, but once you read that formula, we need to change it, because we're asked to find the length, to L equals something. So basically, we've been asked to rearrange this equation to make L the subject. So let's start by jotting down the equation. T is equal to 2 pi times the square root of L divided by 9.8. So the first thing to note, I suppose, is that L is locked away in invisible brackets inside that square root. So I need to get rid of that square root. I can't get to the 9.8 or the L yet. So let's start by getting rid of the 2 pi. That 2 pi is multiplication, and I can really easily get rid of multiplication by just doing some division. So that means T over 2 pi will be equal to the square root of L over 9.8. I can now get rid of that square root by squaring both sides. So if I square all of this, the square and the square root cancel each other out, which means I've got to square this other side here as well. So that there will leave me with T over 2 pi squared, or all of it squared, is equal to L divided by 9.8. I'm now going to go times 9.8, because that's division, so I can get rid of that by times 9.8. So L is equal to T over 2 pi squared times 9.8. Now, I'm a little OCD, so I'm actually going to expand this bracket, but if you did leave it at this stage, you'll probably get full marks. So L, in my case, would be T squared over 4 pi squared times 9.8, and I can even move this 9.8 onto the denominator if I wanted to go an extra step, which I certainly am, because I'm not going to leave it as it is. 9.8 T squared over 4 pi squared. So that there is, in my view, the best answer. But just a reminder, if you did get to this stage here, you got your full excellence mark for that question. So that wraps up all the excellence questions from the 2016 exam. Hopefully you found them really useful. If you got any questions or whatever, comment to this video and I'll get back to you as soon as I can. Keep an eye out for the next lot of MCAT videos coming out soon.